Hey everyone, Radhe Radhe. My name is Aryan Pasha, and today we'll be learning about a really interesting topic that is infrastructure as code. In the previous video, we launched a new course, a new playlist about infrastructure as code, where we'll be discussing about all the prominent tools that are actually present in this whole domain, in the whole cloud domain, which are really helpful in managing the infrastructure of your application. So in this particular video, it will be an introductory video where we'll be learning about what do we mean by IAC, what do we mean by infrastructure at first, and what were some of the reasons behind this particular idea of infrastructure as code, and what were some of the prominent solutions that were available earlier before the launch of IAC particularly, and why do we need to change all those things. And then later we'll talk a little bit about some of the tools that are present in the whole IAC topic as well, like the tools and services that are helpful in managing your infrastructure. So yeah, let's get started. All right, so here's a blog that I published earlier in 2024. I think 2025 is going to have a lot of changes. There's a lot of tools, other tools as well, which are available in the whole infrastructure as code domain, this whole topic. So at the moment, we'll be learning about Terraform and Pulumi. In the later videos, we'll upgrade ourselves, our knowledge to the Crossplane, Ansible, and OpenTofu as well. OpenTofu and Crossplane are some of the most interesting projects at the moment for me, at least. Right. So in this video, we'll be learning about what we mean by infrastructure and what was the need of having the idea of infrastructure as code, what were some of the reasons, and what were some of the prominent solutions that were available at that time when IAC was actually being launched. So first of all, what do we mean by infrastructure? Infrastructure is anything that underlines our application, all the tools, services, supply chains, all those which actually makes our application work, all those tools, everything underline our application uh, comes under the infrastructure, makes up our infrastructure, and we can break down the infrastructure layer into the servers over which our application is actually being uh, taking place in, or grabbing some of the resources in the form of CPU, memory, or some other APIs and services as well, like CI/CD or pipeline automation, testing, chaos engineering, and various other uh, tools as well, and tools and services as well. So that makes up the servers, and then later we have our application layer and the network configuration, where all the major network layer is actually configured with our application. Then we have the database, where all the logs and the local cache of our customers, users, or the developers are actually being stored. So yeah, these are some of the most foundational or the basic uh, level of our infrastructure as code, IAC, our infrastructure. Sorry. So in past, we usually have a whole cycle of business, like of this whole infrastructure. Whenever we want to develop any particular, whenever we want to push any particular feature and deploy it onto our main application layer, we need to first of all get the idea. The business team used to get the idea from the executives and from the executives and the planning committee. Then the business analysis used to happen. It was a layer where the whole main motto of that particular change used to happen, used to take place, and it was actually being analyzed whether it would be a better solution in comparison to the other competitors. Yeah. And then the solution architects used to look at the, the particular request that has been put forward by the investors or the executives or the planning committee, and then they used to build up a kind of a map where the whole the particular security tools or all the particular requirements which were needed to make that change were actually being put as a kind of a blueprint. Yeah, so After the solution architect, we used to have the procurement of all of these engineers. We used to break down each and every particular feature or these or those requests, the particular output that we actually required, that used to get uh, segmented in the form of different roles. Like the field engineers used to take care of their own role, and the system administrators, storage admins, backup admins, application team, they used to have roles according to their own skills. And then later on, all these AWS and Azure and all these providers used to help in setting up the environment of our application, and then the output used to come. But this particular process was actually being really long, if you ask me. Sorry. So that's why the cloud providers actually came into the market, the virtualization, if you ask me. So the modern solution at that time, as an alternative to this earlier idea, was actually the virtualization, like the Microsoft Azure, Amazon AWS, GCP, Alibaba Cloud Foundation, and many other cloud providers used to take care of our storage and maintaining of our infrastructure and all of those things which were actually being required at that moment. Instead of taking so much time in forming up the team and thinking about do we actually need this particular change or not, AWS, GCP, Microsoft Azure used to take care of all of those things. Yeah, so here the cloud, we don't have to worry about most of the things like database center, hardware, assets, and storage. Some of the major features of the advantage of this virtualization was that the virtual machines can spin up in minutes instead of taking a lot of times. Like the whole process, as I mentioned just now, some minutes ago, used to takes up a lot of days. I must say weeks, or might even take months as well. So that must be really frustrating for the investor as well. Like they put that particular request to that any particular company a lot of months or weeks ago, and then to that particular product haven't been finished yet. So that was a really frustrating thing. So that's why it can spin up in some of the minutes instead of taking a lot of time, a lot of days, weeks, or months as compared to the earlier, and the time to market reduced from months to weeks or even days in cloud environment. Human requirement was also actually being reduced because we didn't require so many engineers at that moment. Like we didn't have to take care of the data center or the hardware, so we don't require any help of the system administrators as well. So the system administrators as well either at that moment. So that's why our capital was actually being saved at that moment. So they could save our money. Cloud provides a way to the APIs, which opens a whole new world of security. Yeah, so the cloud providers used to take care of the security as well. Like they have their whole data farms or the servers, which used to take care of similar kind of companies or the organizations, and then they can just adopt a particular security, any particular security solution to all those things or all those servers, so that it can be implemented to all of them, and yeah, security can be enhanced. Building in auto-scaling and elastic functionality of cloud infrastructure reduces resource wastage. Yes, these were some of the things. These were some of the features or the advantages of using the virtualization layer instead of having the whole business and business analysis and that kind of whole cycle. But the problem was that this particular thing was actually also not came out to be really interesting. Things actually can't hold the grip of all those changes that were actually being happening in the virtualization at that moment, because the virtualization was see the immutable structure of all the cloud providers and the whole elastic the elastic cloud services was really frustrating at that moment. The immutable infrastructure wasn't considered feasible. Okay, well, immutable infrastructure wasn't even really popular in Kubernetes either. Immutable structure means that any particular change that has been happening um, at your cluster, the pod, that would be done on the same one that was existing earlier. But the but the mutable one says that the change has to be done on the new pod, the replicated one, so that the security could be enhanced. Security can be kept in mind. If any particular vulnerability has been found, then that can be solved instead of just using the earlier one. And also, they upgraded any particular upgraded feature that has been adopted in your cluster, the workload that could be um, bound to the newer service as well, which is actually being um, replicated and bound with the change that we are actually thinking about. With scaling, manual efforts were being increased. Yeah, sure. Like if we are having different regions, like if we are thinking about setting up an Amazon EC2 instance in US, in East US, and then another one in Europe, and we are having different EC2 instances, different services or the pods as well, then the same UI or the same API. So first of all, any particular tool or any particular service that was actually being uh, asked or requested that used to be that was implemented with the help of APIs. Like the APIs was actually being implemented, was actually being called, and then those services were actually being implemented in your infrastructure. So that actually became and that brought a lot of chaos and like the tedious nature of the whole process. Consistency was brought down on the scaling of our infrastructure, right? Again, our process of infrastructure design got way more complex and difficult to manage. Sure. These problems was being solved with the help of defining. Okay, well, after seeing all these problems that was actually being seen in the whole infrastructure domain, people came out with an idea to defining and managing our infrastructure with the help of configuration files instead of using the UI and all those virtualization layer. We started bringing up configuration files so that we can implement all the changes in our infrastructure and push it onto our application or the infrastructure layer, and then these those can first of all go through uh, the all the changes that were actually being pushed onto our infrastructure layer that can be first saved on the version control, so that people might have been uh, responsible for managing our application could make changes or might even look at do some research that like what were the results that were achieved after and before pushing that particular change to our application layer. So yeah, so instead of using the earlier virtualization or either the earlier uh, yeah, this earlier whole map of using the much tedious cycle, people started using infrastructure as code, like managing our infrastructure with the help of programs and the code, like the configuration and managing them in the configuration file so that we can define our infrastructure, scale them up really easily with the help of different commands or the configuration command files or the language that was actually being adopted at that moment. Like Terraform usually have HCL, HashiCorp configuration language that is dedicated to using or building up our infrastructure with the help of some rules for configuration for building up the configuration files. Although Pulumi is an open source tool that doesn't have any foundation for adopting any particular language for your configuration files either. So that was a new feature which was being pushed in the whole infrastructure layer by Pulumi. Later we'll get to see about or discuss about all the um, differences that Terraform and Pulumi has. The infrastructure. It is a blog that I wrote in 2024. If you want to know, if you want to read more about the whole infrastructure layer, or want to have a good grip over the what do you mean by a Terraform or the Pulumi, then you can have a good read of this blog as well. I will paste the link in the description. Infrastructure and provisioning, it manages out following tasks: spinning up the new services, network configuration, creating load balancers. Yeah, that's all I addressed just now. Configuration of provisional infrastructure, installing application on server, managing these application, prepare infrastructure to deploy an application. Traditional approach was like configuring infrastructure setting manually can lead to inconsistencies and errors, and might even push them onto the your pipe your supply chain as well, which might lead to the bringing up a lot of vulnerabilities as well in the security. So that might not be a good idea. So IAC not only provisions infrastructure but also configures it. You can define the desired state of your infrastructure in code, ensuring consistency across different environments. Tools like Ansible, Chef, Puppet can help with configuration management. Yeah, so here we have the attributes characteristics as well. Like the initial, okay, well, the infrastructure as code was actually being designed in a way so that we can de like define our desired state and then bring up in the like design our configuration file so that we can bring our infrastructure closest to the desired state, what we were what which we desired at the moment at the start. Yeah. So it was all about the infrastructure. What do we mean by infrastructure? Why was it actually being came into the existence? The infrastructure as code. What were some of the earlier or the old cycles, the life cycle of infrastructure that we had, and why do we need to change all of them? And what were some of the prominent solutions that we had? At the moment, Terraform is one of the most dominating tool in the whole IAC domain. Um, Although we have other tools as well, which are really interesting and are really effective, if you ask me, for the infrastructure layer, like which are OpenTofu, Crossplane, and Pulumi. All these doesn't follow any strict principles like where you can only choose one of them. They have different features. They offer different functionalities, so you can even bind all of them, and there doesn't have um, any foundation or what could you use in any particular uh, infrastructure. Like we have cloud specific and the cloud agnostic tools. Cloud specific were bound to use only the foundation of the organization where uh, our application was actually being held. Like the AWS has different IAC tool, Azure has different, GCP, the Google has different. While on the other hand, these cloud agnostic tools, we can use different services and tools and adopt them in the way we want, which includes Terraform, Pulumi, Crossplane. I don't know. Are we discussing about the differences that they all have at the moment? Yeah, see you in the next video. If you have any doubt or if you want any particular topic to be discussed in great details or want me to get to research upon it, so yeah, just ping me on the Twitter or LinkedIn.